Well, this is sort of a rehash of a presentation that I gave when I taught calculus. And I'm going to try to make it shorter because we're not interacting or anything. But what is calculus? Now, one thing that's probably not known to you kids is that the word calculus is not used just in math. If you look it up in the dictionary, you'll find out that that stuff that the dentist scratches off of your teeth when you get your teeth cleaned is called calculus. I've had a few students actually ask their dentist if that was right after this introduction. They came back and said, that dentist said that was right. So it can be dental tartar. Now, why is this usually highest course we offer in high school, and sometimes the first course of a person who's majoring in mathematics? Why is it called calculus? And that stuff that you have on your teeth is called calculus. Because they both come from the word stone. Well, it comes from the word stone, which is something that's hard. I'm afraid that a lot of people think that calculus is hard. And every year that you kids have taken math, fewer and fewer kids are taking math with you. We have lots of Algebra 1 sections, but we get down to just a few calculus sections. And some schools only have one calculus section. And what happens, I think, is that students are confused because math was always easy to them. That's because when you were in Algebra 1, the teacher had to repeat so many times so that they could bring the whole class along. And you thought, well, if I sort of daydream now, I'll pay attention tomorrow and catch up. But in calculus, we don't have time for that, and the students for whom we repeated are not here. So the first important thing that you need to know is that though calculus means stone or something hard, it's not hard unless you try to take a vacation in the midst of the class. You have to stick with everything that's going. Okay? So work with it. And here's some more definitions of it. The way I look at calculus is that it's like the top of this building that we're building. Everything to do with math, from arithmetic, geometry, everything is all the foundation for calculus, and calculus will actually draw everything together. I've had a lot of students that said, I see now why we had to study all those different things. And that's because calculus does draw on any of them. And if you have a weakness in two unknowns or rational functions or something, it's going to come to hurt you. So you really have to make sure that if you find anything from the past that you don't know about, you maybe go back and use some of my programs and get that remediation done. Everything is used in calculus, and anything can be used on a given day. We have the word algebra. It comes from this Arab person whose name I cannot pronounce. My mouth just won't do it. And you see that his name is Abu Jafar, or it's sort of been corrupted down to algebra. And he was because the Arabs were the ones that used the Indian, what we call the Arabic numerals, they were then free to use a letter of the alphabet for an unknown. And then that developed in the subject of algebra, where you could have an quantity that you were going to discover from its properties. And so that word algebra comes from that. And Fibonacci, whose father was a trader over there by Spain and Morocco, is the one who is credited with taking the use of this to Europe. And after not too long, we had two men independently, though I'm afraid sadness and woe during their lifetime, they argued over who did it first. But I think it was that the seeds were sown of algebra, and then that these two brilliant people were able to move on to the concept of calculus, which is really the mathematics of change. So we have Isaac Newton and Leibniz, Isaac Newton in England and Leibniz in Germany, both developed, and most historians think that they developed the calculus independent of one another. They are the fathers of calculus. I like to tell my students that it could have developed earlier, except this guy right here, Archimedes, was killed because of math. He was brilliant, and he lived before Christ. You can see his estimated dates. And here's a mosaic that is showing his untimely death. The story goes that he was doing a math problem in the sand, not on a table like this, and he was asked for his credentials by a Roman soldier. He was Greek, and the Romans had taken over the world, and they said, "Show me your ID," sort of. And he said, "Would you please get out of my light?" And instead of saying, "Sorry, sir, you're the most brilliant man in the whole universe," the soldier killed him. Because if he had lived, it's pretty certain that he had the fundamentals of calculus already established. I like to show an example of how I know that he understood about the mathematics of change and the concept of a limit upon which all of calculus is built. When you were little, you probably learned that the circumference of a circle was pi d. I think in 3rd or 4th grade, the teacher told us that the circumference of a circle was equal to pi times the diameter, or the circumference was equal to 2 pi r. I remember learning it then. And right at the same time, they taught us another formula. I hope you have it in your mind, but let's talk about what this would mean, that the circumference, that the distance all the way around the circle is pi times the distance across the circle. And it doesn't matter whether that circle's small. Every circle, the circumference, the distance all the way around is pi times that diameter. Originally, like, the mathematicians were sort of embarrassed because pi, that ratio, pi, which then is the ratio of the circumference to the diameter of any circle, did not turn out to be a whole number. It was close to 3, but not exactly. And you probably learned 22 sevenths. It's close to 22 sevenths, but not exactly. Actually, it turns out to be an irrational number, which means it cannot be written as a fraction, which means it cannot be written as a decimal. And when you learned 3.14, and then maybe added 159, 265, on Pi Day, we'd have the kids memorize digits of pi, and it just goes on forever and ever. So we will never end up with a person with the most digits of pi that could be done. It probably depends on our machines as to how many we can calculate it. But this is not a number that's readily found out, but there is a number that is the ratio of all circumferences to their diameters of circles. Well, what's that other formula then that you probably learned about when you were a kid? Oops, I'm going too fast. It was the area. You probably learned that formula, and it was pi r squared, or pi is equal to the area of the circle divided by r squared. Now that circumference is equal to pi d is a definition of pi. A definition can't be two things. Where did this area formula come from? I didn't think to ask my elementary school teacher, and probably you didn't either. If we had, we would have probably moved right to calculus. It was actually proved by our friend Archimedes. Archimedes said, well, if we took this circle, and we wanted to know the area. Of course, they already knew about finding the areas of rectangular spaces and everything. We wanted to find the area of this. We could approximate it by making a polygon and cutting it down, and if we added up, we could probably find out using some trig or something, we could find out the area of a piece of the triangle right here, and then multiply by how many triangles we had. That would be an approximation. And how could we get better approximation would be to divided into more and more sides, and the more sides we got, the closer it would be to the area. The more sides we got, the number of sides approached infinity. If we could really go to infinity, we would have the exact area. So Archimedes was thinking along those lines, and let's see if we just unfolded this and do all of this, we would see that this one triangle here has a height which is equal to the radius of the circle. And this little base, this base, and this base, and this base, and this base, we would end up we could find the area of one of these triangles, and it'd be 1/2 of its little bases times the height, r. And then if we, however many we had, the number of bases times that would give us an approximation for the area. And as n got bigger or closer to infinity, our area formula would be better. Well, if we added more and more and more triangles here, and we strung up even more triangles, Archimedes could see that if we took the number of triangles times the base times 1/2 r, we would get the area. And the more sides we had, the number times the base, the closer that this would be to the circumference. So the area is equal to the 1/2 the radius times the circumference, but we already knew that the circumference divided by the diameter was equal to pi. So, or the circumference divided by 2r is equal to pi, and that the circumference was equal to 2 pi r. So we could replace that with 2 pi r. This 2 would cancel out this one, and we would have that the area is equal to pi r squared. This is how Archimedes, probably some variation, he wasn't speaking English, sort of figured out how to find the area of a circular region. If he had lived, he probably would have found the limits of other things. And maybe Christopher Columbus would have had a GPS. Everything, all our technological inventions would have been advanced, because calculus has really brought us a lot of our technologically advanced topics. So, Archimedes could have been the father of calculus, but we credit Leibniz and Newton. I hope you enjoy studying more about calculus and learning more about that concept called the limit. I hope you understood what I was saying about the limit is the number of sides approached infinity, that the perimeter of all those of that polygon inside the circle would be approaching the area, would be approaching the circumference of the circle. Thanks.